Hi students, again I came with an important topic. So it is also requested by a student. So mostly I do videos of requesting by students. Okay, so here see, shown by an example, show by an example. Each of case where the estimate is not unbiased but consistent. Okay, unbiased but not consistent. So in these both cases what we have to do, we have to write one example where these two properties works. Okay, first let us see the first one. Estimate is not unbiased but consistent. Okay, we are taking this case. First we'll see what is unbiased, what is consistent, we have to know. No, so that's why after knowing the definitions then we'll go with the example. Okay, yeah, see here, unbiased. So unbiased in the sense what, it should be fair. Okay, unbiased in the sense it should be fair. See here the definition. An estimated theta cap indicates that we are going to calculate. Theta cap in the sense we are going to calculate. Cap indicates that we are going to calculate. Okay, is unbiased if expectation of theta cap equals to theta, where theta is the true parameter. So that means what? So that means we are going to calculate one unknown value which should be equal to another value. So what are those unknown values in the sense? Here, true parameter in the sense population mean. Okay, that means population parameter should be equal to what? Sample statistic. Okay, that means sample mean. That is called as what? Unbiased. Okay, hope you understand. This is nothing but this is a sample mean, this is a population mean. These both should be equal. If these both are equal, it is called as unbiased. Okay, na? Yeah, if this property is satisfied. Next, what is consistent? See, an estimated theta n is consistent if theta n converges in probability to theta as a sample size and goes to infinity. That means what? If you go on taking the sample size, if you are go on increasing the sample size, that should be what? It should be turned to population mean, population parameter. Okay, hope you understand this definition. So that means sample size, if we increase sample size, if we go on increasing the sample size, that value should be somewhere, it will be equal to what? Theta. Theta in the sense what? It belongs to population parameter. It is nothing but sample statistic. Okay, population unknown constant and this is sample unknown constant. Okay, yeah. And the next is, see, let's see one example they asked. No, so example, consider the estimated theta and so we are going to consider, this is one example, xn plus 1 by n for the population mean mu of a sequence of identically and independent random variables. IID means identically and independent random variables x1, x2 and so on xn with mean mu and finite variance sigma square. That means what? There is one population mean, it is having what? Some observations. Those observations are identical and independent observations. Okay, and their mean is mu and variance is sigma square. Okay, so now let us see these two properties is satisfied with this estimate or not. See here, bias, not unbiased means what? It is biased only, no, isn't it? Not unbiased means this is biased only, so that's why we are checking the bias. Okay, so what is the condition here? Expectation of theta equals to theta we have to get. See here, expectation of theta n equals to what is theta n here? The value of theta n is expectation of xn plus 1 by n equals to, see, expectation should be added only for variables, not for constants. Here x is a variable. Okay, so that's why expectation of xn plus 1 by n. So what is the value of expectation of xn? That is nothing but mu, no? So expectation of xn is nothing but its value is mu. That means the sample mean is equals to population mean. Expectation of x bar nothing but xn is nothing but x bar. Okay, see here. Okay, so that's why here expectation of xn value is mu plus 1 by n we wrote as is. So that is nothing but this value is equal to mu. No, this is not equals to mu. No, we are having extra 1 by n value is there. So that's why it is not equals to mu. If it is equal, we can say unbiased. So if it is not equal, we can say the estimator is biased. No? So first property is satisfied. Okay. So next is consistency. So consistency in the sense what? Theta n equals to x n plus 1 by n. It should be turned to what? Mu. As we told that xn turns to theta. So xn in the sense what? Xn plus 1 by n, that should be turned to theta in the sense what? Nothing but mu, no? So this value should turn to mu as n turns to infinity, as we wrote here. N goes to infinity. So n turns to infinity. Okay. So because 1 by n turns to 0 as n turns to infinity. Okay na? See, 1 by n, the value goes near to 0. At that time n value turns to infinity. So that's why theta n converges to mu, we can say. So therefore theta n is consistent, finally we can say. So this one I'll explain you by taking the numerical value so that you will be understanding. Okay, see here, we'll prove here. See, for example, I am taking n equals to 10 or 100, whatever you want you can take, and it's and also I am taking some samples I have drawn. Okay, some samples I have drawn from normal population with mean 50 and variance 100 I am taking. Okay, and its sample mean is, suppose all these are our assumptions only. So sample mean, I am taking sample mean. Xn is nothing but sample, I told you. So xn, n place I kept 10. So sample n is 52 I am taking. Okay, so these are the values I have taken. And let us keep in this. Okay, see here. Expectation of xn plus 1 by n equals to what we can write here? Expectation of xn plus 1 by n. So what is expectation of xn here? That is nothing but expectation of n is 52, isn't it? Plus 1 by n value is 10. So that equals to how much here? 1 by 10 is nothing but here we get 0.5, no? So 52 plus, how much we'll get 1 by 10? We'll see. 0.1, no? 1 by 10 is nothing but 1 divided by 10. 0.1. So that means what? 52.1. Okay. So this is what? This is expectation of xn plus 1 by n value. Okay, we got this one. Okay, so here this value is not equals to this 50, no? Is it equal? No, no. So actually this both values should be equal, but here we did not get equal. This is a mean mu value, no? Mu value 50, but here we got how much? 52.1. That means these both are not equal. So we can say that it is a biased. Okay, na? So first one, I hope you understand. Now we'll see the second one. So the same example we'll take. So what it is? Theta n. See here. Expectation of xn plus 1 by n. Okay. So here n turns to infinity here 1 by n turns to 0. Yes, now 1 by n turns to 0 and turns to infinity, isn't it? So now we'll substitute the values here. So expectation of here we take, suppose sample size n value 100 we'll take, okay, and mean value x bar 100 equals to some 51 or 61, like that, whatever you want you can take. So now we'll substitute in this. So expectation of xn plus 1 by n equals to expectation of xn plus 1 by n. So what is expectation of xn is nothing but 51 plus 1 by 100. So 1 by 100 is nothing but 51 plus 0.01. So the answer is 51.0001. No? So this is, here we got 51.01. okay, so again I am taking n value 1000. If I take n value 1000, what happens, we'll see. N value 1000, okay, so here, and x bar 100 value I am taking some 50.1, like that I am taking, okay, we'll see what happens. So expectation of xn plus 1 by n equals to expectation of xn plus 1 by n. So expectation of xn, what value we got here? So 50.1 plus 1 by 1000. So 1 by 1000. So 50.1 plus 1 by 1000 in the sense 0.001. So that is nothing but 50.0001. That means this is nearly, we are getting the value 50. So that means what? When we took n value 100, we got how much? 51.01 something we got. When we took the value, when we increased the sample size 1000, at that time we got what? 50.001. That means similarly we can keep this value as 50, isn't it? So that means what happened? If the sample size is increasing, 1 by n turns to 0. Okay, 1 by n turns to 0. That means what? This property is satisfied with this, no? Isn't it? Hope you understand. If you don't understand at any point, so let me know. And in my next video, I'll tell about this second property, this second one, unbiased but not consistent. Okay. So whenever you do this type of problems, at that time you have to, what I say is, you have to compare with some numerical value so that you will be easily get the concept. Okay. Hope you understand. So thank you for watching. If you have any doubts, please comment. Please share with your friends. Okay. Thank you. Have a nice day.